All right, I think it's time to start, otherwise we are going to run out of time. So good morning, good afternoon, good evening. Thank you for joining this Graph Gurus workshop. I'm Szilárd Barani, a Senior Solution Architect at TigerGraph EMEA. Today I will show you how to build improved business solutions with graph and machine learning. In our case, this approach allowed us to double the performance of a fraud detection system. This increase in efficiency was achieved by my manager, Richard Henderson, our lead solution architect in EMEA, whose webinar recording I hope most of you watched prior to this workshop. Richard is also on this call. He will support me with answering questions during and at the end of the workshop. Talking of questions and answers, little housekeeping first. All attendees are muted, but you can ask questions at any time using the Q&A tab in the Zoom menu. All other comments, please send to the chat. Of course, this workshop is being recorded and the link to it will be emailed to you with the slides. An extract of the slides is already shared. You can find the link in the chat window of Zoom. You can use it in case you missed a step and during the exercise you need to go back. If you have any issues with the Zoom, please contact the organizer via the chat. The exercises will be done using a TigerGraph database instance running on TigerGraph Cloud. If you have already created your instance, and I hope most of you already did, please make sure it's up and running. If not, go to My Solution page on TigerGraph Cloud and start it. And actually, I have to do it myself. So I just come here, select Solution Operations, and click on Start. If you haven't created the solution yet, please do so now so that it could be ready by the time we start the exercise, as it takes a few minutes to provision the resources. In addition to this, you will need the schema export that I have mentioned in the prerequisites email downloaded. There is a link in the chat window to all of the resources that we are going to use today that you might need today. You will find the schema export or graph export file as the first link. We will use a Python notebook on Google Colab. This has been shared with you as well. But if you want to use it locally, for example, in your Jupyter notebook, you can download it using the link sent in the email or shared in the chat window. Finally, we are going to import data from a CSV file stored in a AWS S3 bucket. But the file also has been shared with the link to it in the chat. As I mentioned at the very beginning, my goal is to show you how to build an improved business solution with graph and machine learning. In our case, a solution allowed to double the performance of a fraud detection system. Of course, your use case will be most likely different, but the concepts and most of the steps will be still applicable. As I'm not a data scientist, and I do not have the domain knowledge, not at your level anyhow, I won't be able to tell you exactly what application to build, but I can show you how to build it. So here is the agenda how to achieve that. First, we will review the ways we can work with the TigerGraph product and ecosystem. This part will be interwoven by the first dose of hands-on exercises. Then I will review our use case, the fraud detection, and what Richard did and what results he got. This will be followed by the remaining exercises, where we will feed the results coming from the graph into the machine learning model. And as usual, the workshop will end with a Q&A section when we can answer all of the questions that could not be answered during the presentation and exercises. If you would like to know more about our origins and achievements, you will find the information in the slide deck that will be sent to you and that can be now accessed through the link shared in the chat window. Now, a very brief introduction to graph databases and graph analytics for those who are completely new to these subjects. A graph database stores and processes vertices or vertexes and edges. This is based on the concept of graph theory, whose origins can be traced back to Leonhard Euler's 1736 paper on the 7 bridges of Königsberg. So the science behind graph processing and analytics is actually older than the science behind relational databases that really started with E.F. Codd's 1970 publication. Vertices are somewhat similar to database tables or data frames in programming languages and data processing frameworks, in that a vertex, just like a row in a database table or data frame, contains information about a real-life entity like people, companies, products, or about more abstract concepts. But instead of columns, vertices have attributes or properties that could be of simple or complex data types. While a table or data frame is a main unit of storage in another system, in TigerGraph, the vertex instances are standalone storage units. Vertices are often visualized as a circle or a disk, although the shapes or images are also regularly used. In graph theory, they are also called nodes, but that could be ambiguous in a computer science environment where components of a network or a cluster solution are also typically called nodes, so I will stick to calling them vertices. Edges, to me, are the real differentiators that make graph databases completely different from other data storage and processing technologies. Edges represent relationships between real-life entities, i.e. the vertices. This is the important part, as graph analytics is mainly about discovering and exploiting the value of these relationships that often are not trivial, not direct, but require multi-hop deep link analysis. Through these relationships, a graph database can provide context for the analytics. Utilizing the value of relationships these ways is very difficult, costly, and simply impossible with other technologies. Edges can be considered similar to a join or a primary key foreign key relationship in a relational database, but there is a significant difference. In a relational database, a foreign key only describes a possibility of a relationship between two tables, and the join in a query needs to find out if there was actually a link. That is costly. This is why relational data warehouses use a data modeling technique called star schema, which reduces the number of joins. On the other hand, in TigerGraph, the relationships are created at the time the data is inserted and can be seen literally, as you will experience it soon, can be seen immediately. There is no need for extra work to follow the links. In fact, if it is very easy to follow any number of links or hops without any additional work or guessing. This is what we call deep link analysis. We can also say that edges are first-class citizens in graph databases, unlike foreign keys in relational ones. An edge can be undirected, directed, or directed with a reverse edge. Some relationships like friendship are not directed, or the direction is not meaningful or relevant. After all, friends are all equal. In other situations, though, you need to express a hierarchy or a literal direction, like ownership or events following each other. To ensure that your graph query follows these relationships properly, you want to define directed edges to implement them. But in case you might need to go backwards, for example, to find owners of a property, you might also want to add reverse edges. Edges are generally visualized as line or arrow, depending on whether they are directed or not. Edges can also have attributes or properties just like vertices. And this latter feature makes TigerGraph a property graph database. These properties on both vertices and edges can be used for filtering, sorting, aggregations, and in various built-in and user-defined functions and algorithms. Usually, exploring a graph is one of the possible first steps to recognize the often not obvious and long-distance relationships and their values. But operationalizing these findings and insights is the ultimate goal. This can be done by developing queries, which are our kind of stored procedures. They are a piece of code stored and executed in the database at highest possible speed in a parallel fashion and without the need to move data anywhere. We will see an example of this during the exercise. The four main tools to work with TigerGraph are Graph Studio, which is a web interface to design, populate, and explore graphs and to develop solutions. The GSQL command line utility that allows you to enter and execute arbitrary GSQL statements. GSQL, Graph Structure Query Language, is the query and programming language of TigerGraph. It's an easy to learn yet powerful language modeled on, as the name suggests, the structured query language of relational databases. We will take a closer look at it later. The next is the REST API that is mainly used for integration and operationalization and aimed mostly at data manipulation and downstream consumer applications. And finally, TigerGraph, a community-backed open source Python connector intended to be used for data science and data engineering. Your TigerGraph instance should be available by now, so let's get started with Graph Studio. Yes, it's up and running, ready. So I click here on this applications icon, and the first link is Graph Studio, which opens a new tab. Okay. The home page shows every functionality Graph Studio provides. The ones that we will not study today are visual query building us or build graph patterns here. Where is my mouse cursor? This one. And migration from relational databases. We have good webinars if you want to learn more about these. We will also not export the schema, although that's effectively just saving the database metadata into a file. So let's start with schema design on the left side. We are going to create a simple schema for start with 2 vertices and 2 edges. The vertices will be the person vertex and a movie vertex. And the edges will be a friend edge linking person to person and a likes edge linking a person to a movie. To keep it simple, let's have only one attribute for each vertex types, a name for person and a title for a movie. So let's create the person first. Let's click on the plus icon here to create it. Oops, I'm not sure why do I have here. Yes. It's not supposed to be here. Okay, so let's create the person vertex first. When you define a vertex, you need to first specify a name, which must be unique within all of the vertices and edges. Then you need to specify a primary ID, which has the same function as the primary key in relational databases. It can be called anything. It's typically ID or something like the vertex name combined with the ID called, for example, part ID. The ID should have one of the available data types. Additionally, you can specify the styling of the vertex, picking a color and potentially assigning an icon to this. And finally, you can specify the attributes. Like case of an ID, you have to give it a name. You have to pick an attribute type, and you can specify what would be the default value if this data is not provided during loading or not available anyway. Additionally, you can indicate if you wanted an index on this attribute. Indexing, just like in case of relational tables, improves lookup speed but comes with maintenance costs. So index only those attributes that are frequently used in queries. So let's create the vertex. As I said, it is called person. The ID is a integer value. I leave the color as it is. As I said, this person will have a name, which is a string attribute. I'm not going to index or provide the default value for this. Let's create the other one, the movie. It has an ID, again, an integer, and it has one attribute called title, which will be obviously a string. Now that we have 2 vertices, let's create the edges. To do that, let's click on this arrow icon on the top, and then click on the first or source vertex type, and then on the target vertex type. So this will be a like relationship between a person and the movie. Let's call it likes. It's a directed relationship. After all, a movie cannot like a person, but I don't need a reverse it, so I disable that. So it's a relationship between person and movie. And let's give it one attribute called first watched, a simple integer to indicate the year when person watched that movie for the first time. And finally, let's create the last edge for this exercise by clicking on the arrow button again and clicking on the person twice. After all, it will be both the source and the target of this edge. And it's called friendship from person to person. And again, it will have one attribute called since, again, a simple integer to indicate the year. And here we go. We have our first graph per schema design. Now that we have this, we need to publish it to the database because at this stage it only lives in the Graph Studio editor. So by clicking on this up arrow, I'm going to publish this schema. It will take a few seconds. And now that we have these vertices and edges, we can create a graph for this. By clicking on this graph, I can give it a name, simply my graph, which is a typical name for graphs in TigerGraph, and I choose all the vertex and edge types to be included. This might take a while because TigerGraph is going to create the storage structures and optimizes a few things. So let's move on in the, oh, actually it's already done, very good. Let's move on anyhow. And let's jump a little bit ahead. As you can see on the left side, the logical next step would be to map data to graph and then load it. But let's jump ahead a little bit to graph exploration to get a little bit more familiar with what we have created. Oh, sorry, I should have cleared this previously. So graph exploration is, as the name implies, mostly about exploring the graph to find out what we have in the graph, but this graph is brand new, it has nothing. So let's create a few instances of vertices and edges first. Again, very simply, you click on the plus button and you pick which type of vertex or edge you want to create. In case of vertices, I'm picking person, I give it an ID 1 and I call it Szilárd after myself. Let's create another one. ID, which must be unique, will be 2, and let's call it Albert after my son. So we have now two person vertices. Let's link them through friendship. I'm a friend of my son, and since the day he was born. All right, so far so good. This is a friendship relationship, so it's not an arrow, but obviously if it was a relationship called parent or child, it would be a directed edge. Let's create another vertex, this time a movie. ID number 1, this is a different vertex type, so I can use ID 1. There will be no collision with the ID 1 of myself as a person vertex. And let's call this movie Star Trek, the original movie that I'm a big fan of. And let's create a relationship between these two. So Szilárd likes Star Trek. And I, funnily enough, only have seen this movie last year for the first time. So we have now a very simple graph instance with 3 vertex instances and 2 edges. Obviously, in production environments, graph data is not entered manually. This is for illustration purposes. So the 2 steps that we will soon review are defining data sources and data loading rules, plus the data loading itself. But before we do that, let's have a look at another function that is accessible from the Graph Studio's homepage, importing a solution. A solution includes metadata, the definition of the vertices and edges, the schema, the graph itself, the definition of data sources, data loading, jobs, queries, and so on. These are stored and from the database. But the solution also contains information that is only used by Graph Studio, i.e. not stored in the database, like vertex and edge colors and icons, the layout of the schema design, the current and saved layouts of graphs exploration, and so on. In any case, data is not included. That needs to be exported in different ways that we are not going to cover today. The reason we are taking a detour here is that I provided you with a predefined schema that I would like you now to import into your graph instance. This saves us time. We don't have to create a more complex graph from scratch. And we have data for the schema so that we will use later and we can load now. Importing a solution, it's important to remember, importing a solution clears the database. It removes all of the data and metadata already there and creates new object and new metadata, but not data because it's not included. So use it carefully. Exporting a solution is a great tool, by the way, to back up your work. For example, exporting data, your work from a development environment, or to share a solution with others. But yeah, as I mentioned, we are not going to cover this today. So click on import an existing solution and navigate to the file that I have shared a link to. And this is called graph_fraud_export.tar.gz. Open. As I mentioned, it will erase everything. You get this warning, but this is actually what we want, so I allow it to overwrite. This import might take a few minutes, perhaps. Maybe not. Let's see how long will it take. Don't forget, after all, it's a cloud instance, potentially very far from you. So pushing through the export file might take a bit. Next step that we are going to do is actually reviewing what we have just loaded. Almost there. Sorry, this is a step that we couldn't accelerate much. It really depends on the infrastructure between yourself and TigerGraph Cloud. Okay, so let's see what we have here. So we created a new graph loaded a new graph called fraud graph. So let's have a look at the design. It's more complex, but still not a very complex schema. It supports use case, which is about customer buying various products in various categories from merchants through transactions, which have a number of attributes like obviously the amount, dates, and various graph-related or graph-specific information, and these are linked together with these edges. So let's have a look at the data mapping that we have skipped previously. TigerGraph can load or ingest data from a number of sources. The most obvious of these is loading from files uploaded from your local computer, but this is typically done in development and test environments. You can also import data stored in AWS S3 Cloud Blob Storage, the equivalent of Azure's Blob Storage or Google Cloud's Cloud Storage, which are not yet supported, but soon will be. Loading from S3 is what we will do in a minute. In production environments, it's typical to load streaming data using Kafka. It is also possible to import data directly from relational databases, as I mentioned earlier. You can also use the REST API that we will be discussing a bit later to observe data. And there are plans to implement other data sources, such as the previously mentioned cloud storage services, Hadoop, HDFS, FTP, and HTTP sources. What you can see on the screen now, let's zoom out a little bit, is a data source, this file here, and data mapping arrows. Let's start with reviewing the data source first. As I mentioned, we are going to use a data file that is stored in AWS S3. It's a CSV file. This is already pre-configured, so you don't have to do anything, but I quickly show you how this was set up and how alternatively you can load data from local files. Let's start with this later one because it's simpler or easier. So if you want to upload a file locally from your computer, you click on this plus button here. And then, pretend it's not here. And then you click on the plus button again. And then you navigate to the file that you want to upload. This is effectively the same file that we are going to load from AWS, just it's a smaller one to not to waste too much time on data loading itself. So if I open this file, this is uploaded to the server, to the TigerGraph database server. And now by clicking on this, we can tell TigerGraph what it has to deal with. There are a number of options on the top. First, the file format, whether it's text or compressed by any of these listed format, but it's text, so I'm not going to change it. What is the delimiter? It is a comma, automatically detected, but you can pick something else, including tab characters if necessary. What is the end of line character? I just leave it on \n, which is the natural line and character depending on your platform. And enclosing characters, this one is enclosed by, the strings are enclosed by single quotes, so I use this one. And obviously this file has a file header. So I click this one, has header, to avoid loading the header row as data. So this is how you define the structure or tell the structure to TigerGraph of your source data file. I'm not going to do anything here because we have already an S3-based file definition that I'm going to show you. I shouldn't have clicked on that. So if you want to load data from an S3 bucket, then you click here. And then again, you click on the plus sign to set up a data source. A data source will be a description which will instruct TigerGraph what to connect to in AWS. You have to give it a name. It could be anything, as you see here. I created mine as S3DS, S3 data source. And you have to provide the AWS access key and secret key, which can be provided to you by your AWS administrator. I'm not going to show this because it's already set up, but I show you that once it's set up, TigerGraph will show all of those buckets in S3 to which you have access to. Now, I'm going to use this one, where I have only one object or data file, this sorry, CSV file that we are going to use. Actually, it has the same structure, so I'm not going to set it up, and anyhow, it's already set up, but you could configure it as if it was just a file. As you saw, TigerGraph can read data from CSV and similar separated value files like top separated values TSVs, but also from JSON files. JSON is a flexible, technology independent way for data exchange, but this will not be covered today. Once you have uploaded and configured the source files, you can map their fields and columns to vertex and edge attributes and edge primary IDs. This is done by clicking on this double arrow icon and then clicking on the data source and then on the on the target vertex or edge. So let's have a look at it. This orange arrow indicates that this is the mapping that I'm working on. And all you have to do here really is simple. You just click on this first table, which shows the columns or fields of the source data, the data source, and some sample data. And then on the other side, you will see the structure of your vertex or edge, including the primary ID and the attributes. So for example, this is a transaction. I know that the sequence is the transaction ID, and I could map various values here. Obviously, I'm not going to do this because it's not a valid one. But mapping is this simple. I delete this to make sure I'm not going to ruin the experience later. When you, as you can see, you can use one data source to provide data for any number of vertices and edges. And commercially, you can populate a vertex or an edge type from any number of sources. So I could have two files here mapping to transaction, for example, if I have two different sources. A few other things you can do here. So it's not just a simple transfer of data from source to vertices, but you can also use a number of functions. For example, string concatenation to create a composite ID or something similar. And there are a number of string and date manipulation and the data type conversion and other functions at your disposal. Furthermore, you can also specify filters. You can tell which columns, or sorry, which rows to be load or which ones to be skipped, but we don't unfortunately have time for that. Now, I would like you to give it a try. I would like to ask you to delete this edge here between the data source and the customer to transaction edge. It's a very simple edge. As you can see here, we are mapping the ID of the transaction and the ID of the customer to the target and source vertex. And that creates the edge itself during the data load. After all, you define the edge by 5 things: the type, the source vertex type, and the source vertex ID, and the target vertex type and target ID. So I would like to ask you to select the mapping, click on the delete button or trash bin button, and redo it as it is shown on the next slide. Oops, sorry, go back. So simply create on sequence and map it to the transaction vertex, and then pick customer column and map it to the customer vertex. Very simple. I give you a little time to do this. In fact, actually, I have to redo it myself. Sorry for this, but you will see what I'm doing. So I'm clicking on this double arrow icon, mapping the data source to on edge. Sequence goes to transaction, customer go to customer. Once you have done this, once you have finished the data mapping, you need to make it available for the database. Again, this exists at this stage in the editor of Graph Studio only. So I'm publishing this data mapping. In the background, it creates procedures that we will execute next time, data load jobs. Actually, not that it went fast. So let's have a look at the data loading itself. In fact, actually, there is not much to do here really, because all you have to do is click on this play button to start the data loading. And actually, I started and I described the rest for you why it's being loaded. Click. Yes, I want to load these. So data loading is done in parallel fashion is possible. You can also pause and resume data loading, and you can clear the data store. It will only remove the vertex and edge instances, but it will not actually remove the definition. So it clears the data store, but doesn't clear the metadata. It's already done. Important note here, when you load the data to a vertex with the same primary ID or an edge with the same type, same source and target vertex, then the existing instance will be overwritten without warning. This is called upsert. If the new data is not there yet, it will be inserted. If it's there, it will be updated. This could be a good or bad thing. You have to decide what you want and make sure that you know what's going to happen. Well, now that the loading is finished, we can click on the data source and we can have a quick look at the statistics. This is a good first tool to check data quality because it shows how many lines were rejected for various reasons. It shows also the loading speed, and you can see our graph showing the activities and the outcome. So far, so good. So let's move on and go back to graph exploration that we very briefly touched previously. There are a number of ways to explore your graph. Again, this shouldn't be here. So first of all, if you know the primary ID of a vertex, you can quickly look it up by specifying the type, the primary ID, and clicking on this button. But you can also browse the vertex by picking up a number of vertices of the selected types, and you can even specify filters which ones you want to pick up. So let's just do a quick browsing here. So we can see here merchants, categories, transactions, and customers. So let's do the next exploration step, double-clicking on a transaction. Double-clicking displays the first hop relationships, the first hop edges between the selected edge, and it will show which vertices it is linked to through the edge. So very often it is enough just to start browsing and then expanding. Oh, interestingly enough, these two transactions were related to transportation, and maybe this one, yes, as well. So it's very easy to start to understand what is the data we are facing here. Another thing that you can do if double clicking is too much, that you can expand by selecting a number of, it will be too much perhaps, but let's select these two. By selecting these two transactions, I can say that I want to expand it to any other vertex types through any other edges, although obviously you can select which ones you want. You can even specify filters. So let's expand this, and it shows me what are the relationships, and then I can continue expanding this as long as my browser can handle the number of entities to be displayed. Furthermore, very quickly, you can use path finding algorithms, finding the shortest path. One of the shortest paths is all of the shortest paths or all passes between two vertex types, vertex entities, or you can find connections between entities. We don't have time for this today, unfortunately, and you can actually run queries which will return subgraphs, a combination of vertices and edges. We will talk about this a little bit later, but we need to move on now and talk a little bit about queries. As I mentioned, queries are the next natural step and the way to operationalize our findings. Queries need to be deployed in the database, which can take some time. So as a first step, I would like to ask you to install or deploy these queries by clicking on this up arrow icon in a little box. It will take a while, but because TigerGraph is doing a lot of optimization, in the meantime, it's not just uploading the file. So let's install it, and I'm going to provide you a few details about queries while it's happening. So queries in TigerGraph are what you would call stored procedures in relational databases. It's a piece of code name saved and executed within the database, operating over the data stored in the database. And they have a number of benefits. First, they run in the graph, so there is no need to move the data, for example, to pull it out from your database into your Python notebook for analytics. So it saves time and simplifies operation. Second, they can be compiled into machine code. This is what actually we are currently doing at the time of deployment, so that they can be executed as fast as possible without the need to understand and interpret the code by the database every time. Third, the query code is executed in a parallel fashion. TigerGraph is an MPP system, a massively parallel processing solution, meaning that the database might consist of multiple computing nodes sharing the task of data storage, retrieval, and processing. This is transparent to you. No matter if you have only one node in your database or hundreds, the same code runs everywhere and you will see one database only. You don't need to know where specific pieces of the graph are stored. The system will find them for you. Finally, queries installed in the graph have a REST API endpoint so that they can be easily put into production with minimal effort to integrate them with consumer applications. Queries are written in a language called GSQL, or Graph Structure Query Language. Again, as I mentioned earlier, it's closely modeled on the relational database SQL language. So you will find a lot of familiar keywords and constructs if you have relational database experience. Let's have a quick look at it. Of course, due to the unique nature of graph data structure, some specific modification additions needed to be introduced. We don't have time to dive into the language, but we have a lot of resources, starting from documentation to recorded webinars where you can learn about it, and we would be happy to help you with that. The one thing that I would like to say now is that the logic in a GSQL query is very simple. You start with the seed vertex set, one or more vertices, and then expand from these vertices into other vertices through edges between them. And while you're traversing or moving from one vertex to the other, you can specify conditions which edges or vertices should be touched during this traversal. Pretty much it's the same thing that you would do manually in the graph exploration part, from one set of vertices to the other, and then the next one, and so on. The result of this traversal, as I said, is another vertex set which could be the base for the next hop. So this way, hop by hop, you can reach your destination. One hop in our query is expressed as a select statement, and here is one. We start with a starter set, which is all of the customers. And through the customer transaction age, we find all of the transactions, and we do some manipulation in the meantime. Obviously, this is a slightly more complicated query than the usual. But if you have a look at Richard's presentation, I'm fairly sure you will understand what he's doing here. GSQL is called a Turing complete language, which means in practice it's not just a query language like SQL, but it has procedural statements. For example, as you can see here, we have ifs and loopings and so on. So you can write actually very complex real programs in it that runs in the database. And then this is executed in the graph. In fact, the language is so rich that we have a great number of sophisticated graph algorithms developed in GSQL and shared as a library. It includes functions like centrality scores, including PageRank that was invented by Larry Page of Google, path finding, community detection, similarity algorithms, and so on. These are ready-to-cook templates that you can easily adjust to your graph and needs. We are not going to GSQL, as I mentioned here, and we are also not going to cover the GSQL command line utility here, as it is not needed for this workshop. So let's have a quick look at the next way to work with TigerGraph, and that's the REST API. As I mentioned earlier, the REST API is a programmatic interface for the database. We provide HTTP endpoints that return JSON responses, and these functions cover a number of the things like data manipulation, metadata retrieval, built-in graph algorithms, and so on. And as I mentioned, in addition to this built-in default REST endpoints, all the queries that are compiled in the database provide their own endpoints, so you can immediately use it through various tools, including even your browser, or assuming that you have the authorizations to do so. This is all very useful. I mean, it's very easy to operationalize TigerGraph and access it with a great number of tools, but perhaps not the most convenient to use curl or the web browser. This is why we work on language connectors, the first among those being the Python connector called PyTigerGraph. It started as a community initiative with TigerGraph now contributing a lot. It's not officially supported, but you can get a lot of help from the community website, not just from TigerGraph employees, but other Python users as well. It started as a wrapper over the REST API, but we added a lot more functionality, and now it has access to all of the database functionality through arbitrary GSQL commands. The purpose of this is to bring graph analytics results into Python, but don't misuse it. Don't use TigerGraph as a Bitbucket by pulling out everything into Python. Let TigerGraph do the heavy graph analytics and use the results, the output, for example, for queries to enrich your Python model. And obviously, PyTigerGraph being Python, you can use it from Jupyter or Colab or any Python applications to get the data and visualize your findings. And now, finally, reach the point where we can talk about the use case. We covered the tools. Let's look at the use case and the implementation. I hope that you had the time to watch the recording of the presentation by Richard, but for those who couldn't watch it, here's a very brief summary. So Richard was using a public data set and built a machine learning-based fraud scoring application to validate that using TigerGraph or graph analytics gives materially significant improvements. His goals were to make the results explainable and the data and the method replicable, to make sure that the runtime performance is the same or better than the legacy non-graph-based solution, and to minimize rocket science and maximum data science. And the initial outcomes show around 50% increase in frauds detected with a 60% reduction in false positives. The key behind this improvement was real-time generation of new features from the graph. Generating these using other technologies would be difficult, too long, or impossible. As we saw, the schema contains a few vertices describing retail transactions, and those vertices, and let's have a quick look back at this. They have a lot of attributes or properties, and Richard used these and the relationship between these vertices or transactions and person to extract a number of new features in real time over a parameterized history of days. And here you can see the list. I'm not going to go through this, and you can anyhow get more information, better information from Richard's presentation. So he used these, and the results are very convincing. As you can see, using graph data, only around half as much fraud use cases went undetected. And there were nearly 60% less false positives. And the results are also explainable. So you can see, using real-time aggregates and graph context, there is a more detailed picture of what really influence of fraud detections. And then you can see some of these newly generated features have a lot more importance than the traditional the legacy ones coming from from transaction data only. Let's bring this to your notebook. Richard had to develop two functions to prepare the data for analytics. So let's go back to this quickly. These are the two functions, the fixed statistics and fixed transaction aggregates. So let's quickly execute this by selecting the function and clicking on this run button. The first one should complete in no time, and indeed did, while the fixed transaction aggregates probably will take a little bit more, but not excessively long amount of time. And while it's running, it might be finishing soon, let's have a look at the notebook. I have shared the notebook with you, and you should have the link. Let me find the link actually, I can copy the link from, either you can copy the link from the mail that has been sent to you, or I can actually just copy paste from the chat window where I shared it previously. Control C. Here we go. As I said, here we go. Come on, Google. Yes. So this is a standard Jupyter Colab notebook. If you want to use your local Jupyter instance, you can download this notebook, or in case you don't have a Google account, but I'm going to use it in Colab right now. First of all, you have to say, if you want to make any modifications, and we will have to, you need to save it locally, save a copy on your drive. I think I get a new one, yes. So I can focus on this one. And one of the first things we have to do is install a few things that are not by default available in Colab, and probably not available in your computer, might not be available in your computer if you are using a local Jupyter. First of all, we need to install TigerGraph, and Richard are using two modules, Category Booster and these IPy widgets that we need to install, and some modification needs to be made. So let's execute this first cell. It takes some time. While it's running, let's check back to, okay. Don't worry about this. In the TigerGraph environment, we limit the, for a free instance, the execution time for a query is limited, but the query has been executed in the background, so we will be able to use it. So the two preparation steps has been done, and we are going to run from the notebook this main function, which returns over a period of time the new features. So coming back to this, yeah, everything is installed. Let's hide this. Okay, so now that we have everything is ready, there is one more thing that we need to do. We need to set up the connection to TigerGraph. And the details are sent here, but I'm going to show you what you need to do with a little description first of what we need to do. So obviously, TigerGraph is an enterprise solution. It comes with enterprise level, an enterprise solution that comes with all kinds of security features, and the instances in TigerGraph are secured. To be able to get access to this, we need to get a secret. A secret is a small random identifier that are typically provided to you by your database administrators, but because you created the instance and you're the administrator, you have to do it, you have to create it yourself. This secret will be then used by TigerGraph to create a session token. The session token is the authentication token for the session for the execution of the notebook. Don't worry about all of these details. They are partly described in the notebook, and then obviously we have detailed documentation describing all of the security features. And in most cases, for example, if you create a local virtual machine or Docker image, you probably don't have to worry about any of this anyhow. So two things that we have to specify here. We obviously need to tell the notebook where to connect to, and I provided all of the details except the actual URL that you can get by simply copy pasting the first part of the URL from your notebook, which is in my case this stg-workshop. So I just copy paste this, Control C. So this is the unique identifier that the email asks you to create. It has to be unique because this is now an internet domain name, and you have to make sure that you are not using each other's TigerGraph database accidentally. So I copy paste this and replacing this placeholder here. And the next thing is to generate a secret. For this, we have to go back to Graph Studio and have a look at one feature that I didn't describe in detail, and it is the administration pages. Mostly you will use Graph Studio for designing schema, populating it, exploring the graph, and write queries, but you can also do some administration here, mostly monitoring, but also you can manage users. You can add users and specify their access details here. What we will do here, though, is only generating a secret. A secret is a named random piece of string that I'm going to create now, and I just give it a name, my secret. It could be anything as long as it meets certain syntactical requirements. And I have to then click on this plus button. The database is going to create this random string, which will be linked directly to you within the database. This link, this information can be only seen now. As you can see, a previously created secret is obfuscated, so it cannot be used any longer. So make sure that when you are creating a secret, you copy paste it and save it somewhere. I'm going to copy paste this newly generated secret into my notebook here to replace the second placeholder. And that's it. That's all we need to do to set up the connection. And now we start executing the notebook. Again, as I mentioned earlier, I'm not a data scientist. I won't be able to tell exactly what Richard has done this. I more or less understand what's happening, but I can't explain why exactly he chose what he chose to do. You can ask him. You can probably get a lot of information right out of his presentation. I know actually because I have seen his presentation. So what I'm going to do here is just to show you the first few steps and to show that it works. And then we can discuss the rest later in the Q&A part or offline. So now that everything has been installed, I have to import certain things that we are going to use. There are some settings here. Finally, we are going to establish the connection, specifying the token. And here in the first statement and the only statement that is needed, we are going to run this installed query. Going back to here, we are going to use this query installed, which actually, as you can see here, comes with this REST endpoint. So this REST endpoint is wrapped into this Python function, run installed query. We specify the name and the parameters, 14 days of history. The default is 1, so this history is 14. And then you can specify some additional parameters, which is not relevant now. And we get back a JSON document, but we have a function to convert that into Python pandas data frame. I actually make it shorter because I think I'm running out of time. Let's say 3 days. I'm not sure how it will impact the validity of the data, but it's probably not that relevant. So when we are executing this, this is running over, I don't honestly know how many, but several. Actually, I can't tell exactly how many, because if we go back to load data, we can have a look at the statistics. We have nearly 600,000 transactions. So this function is running through the 600,000 transactions plus all of the links, all of the edges, and it should finish soon. But again, because it's running in the cloud, I can't really control, okay, we can't really tell in advance how long it will take. Okay, it has been executed. So let's move on to the next step, next few steps, which will allow us to see the data. And here we go. So there is 600,000 rows of data returned, and these new features calculated over a 3-day period. And the rest is complicated. Data science complicated to me, but I really hope that you have the experience and the skills, and then we'll be able to understand Richard's intention here. Coming back to my slides, now that we actually build the solution, I would like to draw your attention to our community resources. We have a number of resources for the community itself. We have a forum. We have a chat channel on Discord. We have a site for developers, and we are on most important social media channels. And that actually concludes my presentation at the very end of the hour. I hope that you will still have a few minutes to for a Q&A session. Richard, Deborah, did we have any questions that went unanswered? Or do we have any questions that need to be discussed right now? Yes, of course, the presentation will be shared. You are going to get an email with the link for the presentation, and all of this information that I have sent to you, all of the download links will be included in that. Any questions? Any other questions regarding the solution or the data science part? I have several number of questions answered during the presentation, so I'm not sure if we need to wait for any other answers or any questions.
I think that's fine, Szilárd. Yeah, I know Richard covered a lot of questions during the actual session, and you've also shared details of where we can all be reached. So yes. Another question's just popped up.
Yes, I see it. Where does the Jupyter notebook run? So you can use it in 2 ways. If you have Jupyter installed locally, for example, part of the Anaconda distribution, then you can run it on your notebook or any hardware, virtual or physical. We chose to use it, run it on Colab, Google's implementation of a Jupyter notebook like data science collaboration platform. We chose this to make sure to minimize the need for you to download and work with files. In long term, we try to eliminate all of the needs, so it will be all cloud-based. So we use Colab, but my understanding is there are other platforms, and we are looking at those. If you have some preferences, if you would like to see this running on different environments, please let us know. Any other questions? Oh, let me know if I can help it. Actually, that would be really nice. As I mentioned earlier, we definitely want to expand into Azure. In fact, Tiger Cloud is already implemented on Azure, and we are working on expanding to the rest of the ecosystem. And I'm honestly not that familiar with Azure, but I'm fairly sure that there is a similar platform, and we would be happy to work with Azure. It's obviously very, very important platform to us. Thanks, Linda. And I think because so many answers were answered, so many questions were answered during the session, I think we can thank you now, your participation. As I said, you will be given all of the resources that we used today. And here on this last slide, you can see my contact details. Yes, the Tiger is part of my Discord handle, but you will be sure find me by my first name. And thank you very much for your attention. Have a good day and hope to see you back soon on the community channels or on social media or the next Graph Guru sessions. Thank you. Goodbye.